moving on to section 1.4 from your textbook. Okay, today our goal is to see what happens to a graph of a parabola when we change the a value in the graph y equals ax squared. So in other words, what happens when we change the number that's in front of the x squared. Now, the easiest way that we're going to look at is we're going to complete this together on this video. And we're going to complete the table and then graph the three functions on the same set of axes. So I'm just going to get rid of this for a second. So you can see I have some dots there just because it was easier to do that for you, and you'll find it a little bit easier when you have to graph it. Now, what I could do is I could substitute everything into the equation and punch it out and figure out what it is. An actual easier way is with the graphing calculator. And if you notice, we are using the graphing calculator a lot more this year. So y equals, and I'm going to put in x squared. Now, I do know what that graph looks like. But I'm not interested in the graph, I'm interested in its table of values. So if you do second graph, this is what happens. You actually get the table of values for that function. Now I'm interested in starting at -3. So I'm going to bring up -3, and if you notice, I end up with 9. And what I need to do then is I just have to copy that screen into my table. Now I've already done that, as you know I do a lot, and these are the values that I end up with. Okay. Now remember, you can stop the video at any one time if you want. Now the next equation, if you notice, I've changed the a value to a 4. So what happens to the y values when I do that? Again, what I'm going to do is I'm going to go back and I'm going to actually insert the number 4 in front of my x squared. Okay, now when I do that and I do second graph, again, you can see I have numbers here, 36, 16, 4, 0, 4, 16, 36. So very, very easy to see what happens. So I'm just going to transfer those numbers into this column. And finally, I'm going to enter the last equation in. It's a little bit hard to see. It says 1/2 x squared. So this time, when I enter that into my graphing calculator, because I'm not going to enter it as as a fraction, I'm going to insert 0.5 is the easiest way. And I'm going to delete that 4. Now when I do my table of values starting at -3 to +3, you can see these are my numbers, 4.5, 2.50, etc. So I'm going to transfer those. Now before we go any further, let's actually look to see what has happened. Okay, I want to look for a relationship between my a value and the y values that I have. Okay, so here's our most basic parabola. And you can see what happens if I take this 9 and multiply it by something. Oh, look what happens. If I multiply it by the 4, I end up with the numbers in the second column. So 9 times 4, 4 times 4, 1 times 4, 0 times 4, 1 times 4, 4 times 4, 9 times 4. So it takes the y values of my most basic parabola and multiplies it by the 4. Now let's see if that follows through for our third equation. So if it's true, then I would take 1/2 of 9. Oh, well, that is 4.5. Half of 4, which is 2. Half of 1, which is 0.5. So you can see as I go down, this third column I can get from the first column by taking its a value. Now, what does it do to the actual equation when I graph it? So if you notice, I've color-coded these and I've actually put the dots on. Now what happens, I'm just going to click on all of the equations and you can see the green one is the most basic parabola. When I multiply it by 4, I end up with a skinnier parabola. So in a sense, the numbers are going up faster. And when I multiply it by 1/2, what's happening is it's taking those blue values and cutting them in half. So in a sense, I'm getting a fatter looking parabola, a flatter one. Okay, so it's not going up as fast. So what is the relationship between the y values of each parabola? Well, we can say that if I'm looking at y equals ax squared, the y values will be a times those of our first column, which was the equation y equals x squared. So all I'm doing is I'm taking the a that's in front of x squared and multiplying it by the y values. So it's a pretty easy way so that you're not having to, first of all, use a graphic calculator all the time. And second of all, if I have y equals x squared, its y values, I can get any of the other y values. Now let's take a look at the next part. Okay, now this time we're going to, on the graphing calculator, we're going to graph these following things. Okay, so I'm going to see what happens when I increase the value of a. So again, I'm going to bring up the graphing calculator and I'm going to enter the values x squared. Oh, I guess I should have cleared all that. So x squared. The next one is going to be 2x squared. And the last one is going to be 5x squared. So now when I graph it, you can see this is what I end up with. Now I'm just going to zoom in a little bit because I am going to actually take a screenshot of that so that we actually have that. Sorry, so we actually have that in our note as well. Now I realize that's a little bit harder for you to do, but you could actually get it in there yourself as well. Okay, so what we notice is that the graph gets steeper. Okay, in other words, they look thinner than normal. Okay, so this is our normal one, and each time it gets steeper and steeper and steeper. So the y values get larger. So we call this a vertical stretch. Okay, so that's the fancy word, a vertical stretch. It's stretching those y values. So the same would hold true. What happens if I put 10 in there? Well, I would think that that would make it stretch even further. So let's try that. I'll keep all the other ones on there and let's put the 10x squared. And it might even look almost like a vertical line. Oh, see, notice it filled in. So what would happen if I put 100? That may be too much, but we'll do it anyways. Okay, so you notice as the numbers get larger in front of the x squared, it actually it stretches those y values. So that's why we call a vertical stretch. Now what we're going to do is we're going to take our graphing calculator again, and this time I'm going to put smaller values in front of the x. And you maybe can predict already what would happen. So first of all, I'm going to clear all of these. It happens when you enter so many of them. And I'm going to, again, start with my x squared so we have something to compare to. I'm going to put 0.5x squared, and the point, or the 1/5 is the same as decimal 2x squared. And this time, look what happens. So the first one is our x squared, so they graph it in order. And you can see that this time it's become flatter. So again, I'm going to take a screenshot so that we have that in our note as well, so that you can see that it does change it that way as well. So there we go. So we can see, first of all, that the graph gets wider. The y values are actually getting smaller, and we call this a vertical compression. So it compresses things. So think of compressed air, you're making it actually smaller. Okay, so I'll do it in red. So it's a vertical, and we say compression. Okay, so what is the value of A was 0? What would happen if it was 0? Well, we could actually try it. So let's try it. Let's bring up the graphing calculator again. So what happens if we have 0x squared? Well, nothing appears. Now, it could be that our window's off, but actually what it means is we get a horizontal line, which actually is the x-axis. So that's really what happens. Because if x is 0, it means that, or sorry, if a is 0, what it means is anything multiplied for the x squared is going to come out as 0. So we end up with actually a linear because it's gotten rid of the squared on us. So now let's see what happens if we actually have negative values for our a. There again, you might be able to predict what that would be. And I'm going to get rid of this last one I did. And let's do negative x squared. And let's just graph it by itself. Oh, I just guess I didn't get rid of that one. I'll clear that one and go all the way up to the top. Sorry about that. Negative x squared. Well, it turned it upside down. Well, what happens if I have, oops, let's put a negative 0.5 x squared. Okay, remember the first one is going to be on. Oh, so it gets flatter. Okay, but it turns down. What happens if I have a negative 5x squared? So again, if I enter that in as my third one, negative 5x squared. Okay, it gets stretched, but in the negative direction. So that gives you an idea of what happens when you have a negative. So it just makes it flip upside down, if you want to say that. In other words, it makes it open downward. Okay. So in conclusion, what we can say is that it makes the y values negative. So the parabola is reflected to open down. Okay, so that again gives us some kind of indication. Okay, so we're not quite finished, but I am going to stop the video right now just because we're going to be moving on in general and doing then just a couple really quick examples together. Okay, so stay tuned for the conclusion of today's lesson.